Okay, it is 10:05 where I am, so it's already 5 minutes past the start date of this webinar. And so we're just going to go ahead and get started. And I'm going to start by talking about the agenda of this webinar. So those are the things we're going to be talking about today. First, I'm going to be introducing myself, and then I'm going to introduce the T for Design School, the host of this webinar. We're going to talk about the 3D CAD market size, and then we're going to dive into parametric modeling, and then we're going to talk a little bit about what SOLIDWORks is, the different specializations there are, and then we're going to do a very small hands-on demonstration on SOLIDWORks 3D modeling. And then we're going to have an open floor to questions. So I'm going to start by housekeeping stuff. So this is a webinar using Zoom, and so there is a chat with this webinar. Feel free to use this chat in whatever way you feel like it. Feel free to introduce yourself. Let us know where you're joining from. You can share your LinkedIn profile, and you can connect with other people who are here in this webinar. So the chat is your space. Feel free to use it in whatever way you feel like it. The second item is about questions. If you have any question during the webinar, you can directly just post it in the chat and we'll get to it. We'll have a segment at the end of the webinar for Q&A. And in that Q&A time, we're going to be devoted to questions and answers. And now, let me introduce myself. Please allow me to do that. So my name is Taysir Al-Matar. I have a background in mechanical engineering, so that was my first degree. And then my second degree was in design. Specifically, it was a master's degree in international design and business management. And through my career, the area I've worked most in is areas of learning and development. So this is talking teaching people firsthand, designing curriculum, conducting quality assurance on institutions, big and small, and try to improve the quality of learning. Most of the areas I've been involved in are quite technical in either mechanics, as in maintenance, machining, or in design, in bigger design areas that include design as an approach for innovation. This includes design thinking, user research, lifestyle research, and so on. Specifically on SOLIDWORKS, I have been training people on that since 2015, and I'm very, very fortunate to have had the chance to train thousands of people from across the world. And that ended up getting me a book deal, and I published my first book on SOLIDWORKS called Learn SOLIDWORKS 2020 back in 2019. So that's about me. So now it's your turn. Again, we have a chat that is accompanying with this webinar. Feel free to use it in the way you feel like it. Do introduce yourself there and at least let us know where you're joining from. I see two people who have posted in the chat. Rostin from Malaysia, welcome in, and Joan from the United States, welcome in as well. Very, very happy to have you here. So yeah, the other guys who are here, we have much more participants than two. Do not feel shy. You can feel free to use the chat and just introduce yourself and let us know where you're joining from. I hope to hear from you. Darian from the United States, welcome in as well. So this webinar is hosted by the T for Design School. And the T for Design School is an independent learning platform that provides accessible quality learning experiences to lifelong self-driven learners on on-demand design skills. Those include 3D modeling, which the school started with, but now have expanded to other areas, including 3D printing, simulation, work portfolios, and sustainability. Now we can go ahead and start talking about the topic of this webinar, which is 3D CAD and parametric modeling. And I'm going to start with some numbers. So if you are watching out for what people are into nowadays in terms of skills, you would note that there is a lot of focus on IT skills. Those include programming languages like Python, that is becoming a big deal right now. Data science is an area that is growing as well. UX, user experience, or UI design is growing as well. But a lot of people have mistakenly started ignoring 3D modeling, and we started ignoring things that relate to the physical world around us as more and more things move into the virtual world. However, numbers do not agree with that. The global 3D CAD software market is growing, and I got the numbers here from verified market research, and they're projecting it to grow from about 9 billion in 2020 to 14.23 billion in 2028 at a compound annual growth rate of 6%. So don't be fooled by what people are into nowadays. 3D modeling is growing and will keep growing for the foreseeable future. So if you're thinking about getting into this area, do feel free, not feel free to go into it, but do know that it is a good time to get into it as well, and just have it as a skill. It's quite fun as well. I would say more fun than programming. That is my biased opinion, probably. So now let's move into parametric modeling. So when we're talking about 3D CAD design, we are really talking about mostly parametric modeling softwares. Parametric modeling is basically the core principle of all those parametric softwares. And those, you're talking about SOLIDworks, you're talking about CATIA, you're talking about Fusion 360, Inventor, FreeCAD, SketchUp, which changed to another name right now, and all those other softwares all function on parametric modeling principles. And in a nutshell, parametric modeling is 3D modeling based on relations and logical arrangement, basically geometry on steroid, if you want to call it that. And it is optimal for applications that end in manufacturing. So if you look around you, I have a camera in front of me, I have a laptop, I have a keyboard, I have a mouse, I have a table. Everything that is done and ended up becoming a physical object, there is a very, very high likelihood that it was designed using a parametric 3D modeling software. And I know in this slide I haven't defined parametric modeling as much, and so I find it easier for people to get what that is if we do a mental exercise. So let's go ahead and do a mental exercise together. You don't need papers, you don't need a computer software, you don't need anything. You can just imagine the situation right here. So let's go and start with an exercise. And this exercise is about a square that will eventually turn into a cube. We have one of the in the chat. Rhino 3D is another software with parametric capabilities. Yes, Rhino 3D is also a big software in the field at the moment. So we have 4 lines, and those 4 lines can turn into a square. So this is something quite simple, and if we have been fortunate enough to end up going to a school, either elementary school or secondary school or high school, depending on where you are, we know that because we did geometry there. However, if you're talking about parametric modeling, especially from a software perspective, there is much more depth into that principle of a square. And so let's dig into that a little bit deeper. And if we do, we can end up with something that looks like this. A parametric square is a square defined by parameters. And those parameters are dimensions and geometric relations. And so here we have a merged relation between each end of two lines. Those two lines here have a right angle. Those other two lines have equal lengths. Those other two lines have another right angle. Those are all geometric relations. And then we have a specified length as well. And in this case, it's 1 millimeter. And so this is basically a 1 millimeter cube defined by different parameters, which are geometric applications or geometric relations, sorry. If we move one step further, we can turn that square into a parametric cube. But before we move into that, we can call this square we have here as a sketch. So this is a 2D thing. We're just going to call it a sketch. It's a parametric sketch of a square. If we take that sketch, flip it in a side, and just extrude it upward to a certain length, then we end up with a parametric cube. And again, we have another geometric relation here, that is the length of the extrusion is equal to the length of the side. And this ends up with a parametric cube. Now, again, we are human beings and we're smart. And when I describe that cube, your response might be something like, well, okay, we all know that it is by default a cube. And if you think that, then yes, you are correct. However, what we are dealing with, especially when we're doing parametric 3D modeling in a software, is we are talking to a robot. And robots are not very smart to understand what we want or what we mean by shapes. Because unfortunately, at least for now, robots didn't go with us to study geometry. And this is one of the things, if you're getting started with parametric modeling, keep in mind that you are talking to a robot. And the biggest issue I see with people who are learning, especially starting to learn a parametric modeling software, is they kind of lose the concept that you are talking to a sort of robot. And because you're talking to a robot, you really need to tell the robot every single parameter you are thinking of. You have two lines. Well, you want those two lines to be parallel to each other, then you have to say that. You want those two lines to be perpendicular to each other, then you have to say that. You want the end of two lines to be merged with each other, then you have to say that. You cannot just assume that by sketching a square or sketching a few lines. Now, another question at this point would probably be, okay, so we worked hard to define those parameters, and then we ended up with a cube. But, why should we, go over the hassle? I can go to Microsoft Paint, and I can draw a few lines, and I can end up with a cube without having to worry about defining those parameters. Probably going to be in a faster time as well, or I can sketch by hand, and that'll be faster as well. But here's where parametric modeling comes into, gains power and gains advantage. And it's this. Let's change something, right? So we just did a virtual or imaginary 1 millimeter cube. Now we've realized that, oh no, we don't want a 1 millimeter cube, we want a 5 millimeter cube. So then what do you do? Well, if you're doing it on a Microsoft Paint, for example, or if you're doing it by hand, then your response would be like, okay, and then you would have to kind of redraw the whole thing all over again, or you'll have to move every line in the cube to make it bigger into 5 millimeters. However, that's not the case with parametric modeling, because in parametric modeling, we have defined every single relation. We have defined how every single line, how every single point will interact with each other. Then we can simply go back to our original sketch that we did with a 1 millimeter side, and then scrap that 1 millimeter, type in 5 millimeter, click on enter, and all of a sudden the whole cube changes from a 1 millimeter cube to a 5 millimeter cube. Now, a cube is a very simple example that we're talking about, but that goes with everything else. So I have this water bottle right here. This water bottle have a diameter at the for the cap. A lot of times in the design process, you're going to have a diameter of maybe 10 millimeters, and then you're going to realize that, oh no, 10 millimeters maybe too small, and then you're going to change it to 11, maybe you're going to change it after that to 12, and then you change it to 13, and then we're going to keep changing every parameter of the design, because going back to a very fundamental design principle, and that is design is circular. And so every product you see around you, if you go to the background of this, there has been most likely a lot of modification in the design itself. You design it with specific parameters, and then you do a little bit of change. You change the height, you change the diameters, you change the thickness, you change everything. And then you keep prototyping and you keep experimenting. And that goes back to a fundamental design principle, which is design is circular. And this is why parametric modeling is used all the time with anything that ends up being an actual product, because you input your parameters, you input your design intent, you set everything up, and then you change and change and change and change, and you go over design cycles in a matter of seconds without having to redo the work over and over and over again. So this is the very major advantage of parametric modeling. And we're going to talk about that more when we go into the software and then see that firsthand. Here are some other advantages of parametric modeling as well. First of all, just like we mentioned earlier, the ease of modification, which we just talked about. And then another advantage is the ease of creating families of parts with similar parameters. So in the exercise we did just now, we created a 1 millimeter cube. However, in practice, if you're in real life and engaging in the design process, a lot of times you might be going like, okay, I don't want to create just one 1 millimeter cube. I want to create 10 different cubes. And then I want to have each cube to be of 1 millimeter increments. So I want to have a 1 millimeter cube, a 2 millimeter cube, a 3 millimeter cube, until you go to 10 millimeter cube. Those, you can think of those as families of parts that have very similar parameters. And in a parametric modeling scheme, or in a parametric modeling environment, it's very easy to create those families, because you just create one, and then you create all the variations based on that without having to recreate anything else. Same thing goes with any families of parts or any families of product. You create a water bottle, you want to create different sizes of it. You want to create different diameters of it. And those are families of parts. Another advantage is it's easy to communicate your design to manufacturing establishment for manufacturing. And again, because we're defining our design based on parameters, so we already have the dimensions, we have all the geometric relations set up. And so then we can easily extract those through an engineering drawing, which softwares adapt to that. And then we share that engineering drawing to a prototyping facility or a manufacturing facility, and then they will use that as a contract between you and them, and that will communicate all the parameters you are needing or you're wanting to have in that particular design. So that's another strong point for parametric modeling. So this is about parametric modeling in general. Now let's talk about softwares. Because parametric modeling kind of made those stuff easier, softwares saw a market in this, and then so they came to adapt to those needs. So now softwares have tons of features, especially parametric softwares have tons of features that cater to anything that involves the actual making of a specific product. So now you can design a cube, or you can design a table, and you can assign materials to it. You can easily take that 3D model you made and automatically generate 3D engineering drawings that you can use for communication. You can do a lot of design evaluation functions. For example, you can do mass properties. You can design something, assign it a material, and figure out the mass of it. You can do symmetry analysis. You can do thickness analysis, curvature analysis, and all type of analysis that can make it easier to understand what you are designing and what the impact, what are the features of your design in real life. If you're doing something more dynamic, you can also calculate the moment of inertia, for example, which is quite important for those particular applications. Another thing software adapted to is simulations. Now, a lot of parametric softwares, including SOLIDworks, Fusion 360, CATIA, and so on, have a lot of simulation functions as well. And simulations allow you to verify your design before you even prototype it. So, for example, I designed this mouse. I want to verify that if I drop this mouse, it will not break. So then I design it in the 3D software, and then I do a drop test, a virtual drop test using a simulation tool, and then I can figure out if this mouse is likely to break or not before I even attempt to prototype it. And that, of course, saves tons of time and tons of money as well. You're talking some serious money in saving, because now everything, you can do a lot of things in the virtual environment to supplement your work in the physical environment. So those are how softwares are coming to adopt as well. Again, if you have any questions in anything I mentioned just now, feel free to just drop it in the chat, and we will address it either in the middle of the session or at the end of the session. So now let's move into SOLIDworks. So SOLIDworks is a textbook example of a 3D CAD software that utilizes a parametric modeling approach. So everything we talked about parametric modeling, everything we talked about in terms of software adoption is available in SOLIDworks. And currently, as we're talking, SOLIDworks is in a professional sense, or in the professional, or what's classified as professional users, business users. That is, today, SOLIDworks is the #1 software in that field. Second to that is, I believe, Fusion 360, if I remember the last statistics I've seen. So it's a very popular software, and it became an industry standard for many regions, in that manufacturing facilities, a lot of times manufacturing facilities will also accept native SOLIDWORks files to communicate your design for manufacturing, which is so far kind of not the case, or not as widespread compared to other softwares. So that's what SOLIDWORks is. And moving into the areas that the stuff that you can do with SOLIDWORks is, it's easier to explain those when we're relating them to the certifications that are available for SolidWorks. So this plot, this graph shows the different certifications that SolidWorks have. And so from those, you can have an image on the different fields SolidWorks as a parametric software gets involved in or gets used at. A lot of those are very similar to other parametric softwares as well. So if you guys in the present in this webinar, if you're using other 3D softwares, you can let us know what is available, how do they compare to each other as well. And if you're just starting in SolidWorks, the CSWA, CSWP levels, which are the associate, professional, core levels, are probably, they would have everything you would need. And I think 99% of the people that you find out there using SolidWorks are probably in the associate level, which is the first corner right here. This is kind of the core of 3D modeling as a mechanical application. And this is where most of the users are at, and this is where most of the applications are at. If you want to go to the professional level, you're already high up compared to most other people. The other applications are all specializations. So, for example, you can do sheet metals in SolidWorks, and it's good. However, unless you're working directly with sheet metals, then most likely you will not be using that package. Same thing with weldments, same thing with surfacing, same thing with molding or mold making, sorry. Unless you're working specifically in those areas, you will not need to use any of the specialized tools that are specific to those areas. So if you're just starting, look for associate level and look for professional level, and 99% of the times, that is all you need. So those are the specializations in SolidWorks and what the different things you can do with it. Now let's move into a small demo. So I just got this sketch right here. This is a sketch of a table. It's not the best of sketches out there. However, it does get the message. So what we're going to do now is we're going to just take 5 minutes. We're going to move into the SolidWorks environment. We're going to show you the interface of the software, and we're going to show you, kind of demonstrate the steps, and then you can have an idea of how easy is it to use or how difficult is it to use, and if that would be of an interest to you. Again, we're going to be using SolidWorks. However, if you're thinking about other parametric softwares, very likely it's going to be quite similar in a way. So this is our table. What we're going to do is I'm going to move to the SolidWorks environment to make it. So this is the SolidWorks environment. This is what you see when you open a SolidWorks file. And the first thing you would do is you go to New and open up a new part. When you go to New, you have a few options. You can do a part, you can do an assembly, or you can do a drawing. However, we're just going to do our whole table as a part. So I'll just go ahead and click on the part option. Wait, I think I need to share the SolidWorks. Okay, so I just thanks, John, for noting that. So this is the SolidWorks environment. Let me restart that. So this is the screen you get when you first start SolidWorks. And the first thing you do is you start a new part. So I'll go to New, click on that, and now I have a number of options. And I have a part option, an assembly option, and a drawing option. For now, we're just going to do the part option because we just want to demo that. So I'm just going to do the whole table as a part. So I'll go ahead and click on that. Now, SolidWorks, this is the SolidWorks environment. The bigger part here in the middle, I usually call that canvas. The part on the left is called design tree. And the part on the top is basically the commands center, if you want to call it that. This is where you do all your commands and orders. So when you do a part of SolidWorks, you always follow the same steps. I think probably similar with any 3D parametric software. You start with a sketch, and then you apply a feature. Just like we did in our exercise of a cube, we did the sketch of a square. How do you do a square? And then we did our feature of extruding that square. So we're going to do the same thing. First, of course, is we need to find a place to put the sketch at. So we put the sketch on a plane, because otherwise the canvas we have is kind of an infinite space, or you can think of it that way. So I'll go to my front plane, let's say, and then select sketch, which pops up right there. And now I can sketch. And what I'll do is I'll do my table. So I'll do the table I just showed you in the last slide. And the table will had a square top. So I'll just draw in a square. So this is a square. Now I'm going to define the parameters of this square. So first of all, I have this side and this side are equal to each other. So I selected them. Now I can add the relation as equal. And then I can set up another parameter, which is the dimension of that table. So I can go to Smart Dimension and adjust the other parameters, the side, which we have as 500 millimeters. So now we have our sketch, and that is fully defined with the parameters we need. Now I can go to Features. In my case, I'm going to use Extruded Boss. Again, I'm just going to do a quick demo, so I'm not going to spend a lot of time explaining things, because I just want to show you how it looks like. And here, in the Feature Property Manager, those called Property Managers that pop up with every command, I'm going to set the dimension from 10 millimeter to 50 millimeter, which is the thickness we want for the top of the table. Now we have it, visible as a preview in the canvas. Click OK, and we just started the top of the table. Now I can do the legs. To do the legs, I can do the same thing all over again. Sketch, and then apply feature. Now I'm going to locate the sketch on this surface right here. So I'll go ahead and do that. And then I will do a leg, which is basically another square. So I'll define the parameter again. The sides are equal to each other. And the thickness of that leg we have is 50 millimeters. So I have one leg. Now I want to copy the leg to 3 times. And so I don't need to recreate it again. And that's an advantage that you get with the parametric approach, is you can do a parametric relation to generate the other sketch. So I'm just going to do a line. I'm going to have a center line. And then I'm going to mirror the square I just created. So I use the mirror command. I'm going to have those 4 lines. I'm going to mirror them around this line we just created. And here we go. We have another sketch. And I'm going to do the same thing at the bottom real quick. I'm going to do a center line. And then I'm going to mirror. And then I'm going to have those 2 cubes mirror to the bottom. Now I have my sketch. Notice that I only fully defined the first one with the parameters we want, and then I just copied it to the different places. And then again, apply a feature, and then the leg is 450 millimeter. So that's it for 450. Click on the green check mark, and I have my table. I have a chat entry right here about recording the session. We have the session recorded, and later on, I'm going to share a recording of the session. I'm going to talk more about the recording of the session later on as well, and how will that be sent to you. Anyways, back to our demo. That's basically it. We just got ourselves a table. Now, there are a number of things that we can do with it as well. Let's say our client goes like, okay, I want to create this table using maple wood. How many kilograms will that be? Well, okay, then I can go to materials. Again, this is part of how softwares adapt to the making of things. So I can go to materials, and then I can assign a specific structural material to this table. In this case, I want to have it as maple wood. And then I apply that. Now I have a maple wood table. And then I can go to my design evaluation functions, go to mass properties, and I can have the calculated mass of that particular table. So now, before I even prototype it, before I do anything, I know that if I make this table, it's going to weigh about 8,300 grams, which is about 8 kilograms. And that's a relatively heavy little table. And then I can use that finding to formulate design changes to fit my need. So here we go for a demo. Another thing we probably think about all the time is adjustments. So let's say the client all of a sudden goes like, okay, I don't want it to be 500 millimeters. I want it to be 450 millimeter table. And then adjustments will be quite simple. Just like we did in our mental exercise, we go to the sketch, we edit that original sketch we had. We had 5 millimeters. I can change that to 450. Click on the green check mark. And we have our new table dimension to 450. And if I go to the mass, now the mass of it is 7 kilograms. So now it's like 1 kilogram lighter than before. However, what I wanted to highlight here is note how once I change the side of the table from 500 to 450, all the legs kept on place. And this is because those legs were set up, were defined using specific parameters. So now I just update the length and everything updates accordingly. If we don't have those parameters, or if we set up those parameters incorrectly, and then we change the table to 450, very likely the two of the legs will be shortened out, and then we'll have two legs hanging in the air, which luckily doesn't happen thanks to the parametric approach of a software like SOLIDworks. So this is about it for the small demo I wanted to share. And let me go back to my PowerPoint slide because I have other things as well. So just now we did a demo and to create this table, and we took probably like a bit more than 5 minutes to create it. Again, in the same software, I can easily generate an engineering drawing. So then I take that model I created, put it in the drawing function. If you remember, we put a new, there was a drawing option, and put that there. And then I can generate a drawing that I can give to a manufacturing facility or give to a person who can make the table for me. So this drawing I'm showing here is a drawing I've created in SOLIDworks as well. Moving into more complex things. So in this example we did a simple table, and we used a little bit of sketches, two little bit of features, and then we had a simple table. However, if you want to do a more complex part, what we do is we build those simple steps until we end up with a very complex part. And here's an example, right? So the table on the left, I just created using two features in 5 minutes. The rotor on the right, I created using 11 features. And you can see that the rotor is a relatively complex structures. However, regardless of how complex the structure is, it can always be simplified into simple steps, simple features that you build one on top of the other, and you end up with a complex part. Now, once we have a number of complex parts, we can mix them together to make an even more, or an exponentially more complex assembly. And here is an example of that. So the rotor we created with this 11 feature, you can see it here in this assembly of a turbine. And so this turbine contained a number of simple parts put together to create this massively, what would be considered a complicated assembly. However, if you break it down, it's really one simple step at a time. And this is an assembly that we have. I'm not sure. I don't remember exactly how many parts. I believe about 50 parts that are included in this assembly. If you include the bolts, you'll be running on 100 plus parts. So that's another good feature that parametric softwares often allow you to do, is you do separate parts, you mix them together to form an assembly. And again, that goes back to their focus on, that goes back to their focus on designing things for manufacturing. And so every part you have around you, including the simple bottle, will probably have more than one part. Probably have 5 parts at least put together to form this bottle. And so in a software like SOLIDworks or other parametric softwares, you would design each part separately and then put them together to form a full product. So that's most of what I wanted to share for this webinar. Again, use the chat. Any questions you have, you can just put them in right there. So now that you started, you can, if you want to join the T4 Design School for more learning, you can feel free to join us as well. We have probably the most affordable package if you're trying to experiment with things, would be our subscription package, which we can use to access 2 of our major offers, the associate level and the professional level offers. And those will take you from doing a table all the way to doing this turbine. Of course, it's a long journey to go, but it's a manageable journey as well. And if you join it, I mean, the approach we're dealing with at the school is quite the opposite of anything you see on YouTube, for example. This is actually this is the story behind the school, is that we kind of noticed that, especially for people who use YouTube, is a great source. However, a lot of the resources there are some are good, a lot are not so good. And if they're good, they're often random a little bit. So people consume those resources, and then at the end of it, they do not really know where they're at. They don't know where they started at. They don't know where they're ending at. And they do not know what they do not know. And then a lot of times when I see models created by people, the parameters are kind of poorly defined. If you use GrabCAD, for example, and download models from there, a lot of the models are quite look beautiful, but they're the way they're structured are not adherent to best standards that this software, parametric softwares can provide. And so that's where we started at the T for Design School. And so we're very strict on structured materials. You know where you start, you know where you're ending. And then we also have support. So anytime you have a question, we're there to answer. And we have regular office hours as well that can answer your questions. Basically, we're trying to eliminate the stress, we're trying to eliminate the frustration, and we're trying to eliminate the time wasted, going through different random sources. So that's about it for the T for Design School. We would love for you to join us. If not, stay tuned. We'll probably have more webinars coming as well, open webinars like this, maybe talking about more advanced topics in the software. And ending in Q&A. So we have a question from Bilal. Is it necessary to acquire CSWA certification if one is getting started? Certifications are okay. I mean, some people look for certifications to put them in their resumes to prove that they know the software. Is it necessary to acquire? No. Is it necessary to acquire any certificate? No. You don't need the certificate for anything. It really depends on your usage, or it depends on your application. I think for many people who are looking for jobs and trying to have that in their bundle of certification in their resume, then a certification would be good to prove that you know the software. However, if you're trying to use the software for your hobby projects, or if you're for your own company, and you don't need that verification, then you can forget about the certifications. So yeah, it really depends on you. Do you need it? Do you not need it? There's no set answer to that. If you're just using the software for your own good, you don't need it. You only need it if you want to show it to somebody. Basically, that's the answer, or my answer at least. Another question: any tips for knowing just the right amount of parameters to apply features, models, enough to be rebuilt, but not so many that as to overcomplicate it? I would say software like SOLIDworks, that's a good advantage of SOLIDworks, is it gives you an indication on your sketches. So most of the time you're defining your sketches. Those are like the more important parts or more common parts to focus on in terms of parameters. And what SOLIDWORKS does is it color codes the sketches. And so you have blue sketches, meaning they're not defined enough. And then you have black sketches that are defined just enough. And then you have red sketches that are over-defined or have contradicting parameters. So if you're using a software like SOLIDWORKS, I'm not sure about other softwares, you can use those color coding as your first guide, especially if you're just starting out. Other than that, you kind of do develop a sense of it over time. If you are drafting something, if you're designing something, and you kind of have an idea of what is important in the part, and I would refer to, I usually refer to those as design intents. So every time you design a part, you kind of have to ask yourself, what are the design intent of the part itself, of the design itself? And then you have to, the best practice is to define those parameters, essential intentions in the part itself. And so it is kind of hard to explain. We do have a blog we have our T4 Design School blog, and one of the blogs we have is about specifically about design intents. So you can check that out and have a read on it, and that will give you a little bit of an idea as well. But to answer for a short answer, you have sketches color coded as a starting point, and your kind of sense of design that keeps growing the more you use the software and the more you're designing stuff. So that's my answer. I hope that answers the question. Can you suggest an online learning path so that one could get to the professional level, including modeling, simulation, analysis, using SolidWorks specifically? Another question from Bilal. Well, I'm going to be biased in this question. I think you can just join the T4 Design School, and then you can start with the CSWA as your first step. You can jump to the CSWP after that, and then you can also jump to our simulation course after that. We do have a simulation package offer as well there. So those are the, I guess, a learning path that you would start with would be like that, which would be most fitting for most people. Again, if we go back to the certification graphic, the starting point will be here in the CSWA, perfect starting point if you're just starting, and then CSWP is your second step. And then the other steps, I would say maybe you would only jump to them if you are using them. If not, you can just ignore them altogether. Simulations is kind of another path. So you start with CSWA simulation, and then you move into more professional levels. However, I would not recommend you to start with simulation until you have a professional level ability in the 3D CAD itself, because they do interact with each other. And then if you're using simulation, you really need to modify your models for simulations. So that's, I hope that answers your question. Any thoughts on SolidWorks versus Fusion 360? That's a tough question. I wouldn't say I have much of thoughts. I think for many people, they do the same, very similar stuff. SolidWorks is considered as for whatever reason, it's considered like a higher level software compared to Fusion 360. So within the hobbyist, for example, Fusion 360 is very common, because Fusion 360 is, you can access a hobby version of it easily compared to SolidWorks. So that's where Fusion 360 kind of reside most of the time. We have a video, we published a video some time ago on YouTube on our channel as well, which you can check out, on which 3D software should you use. And there is really no answer to that. Most likely it would more depend on where you're at, what software are being used for companies in your area, what software does your company use, or if you're in a university, what software does the university use? And then you would probably start from there. However, which is which, it's a very difficult question to answer. You can do 3D modeling in both. As I mentioned earlier, on professional level users, SolidWorks had the advantage of being more used. So if you're looking for jobs for companies, a lot of the times they would ask for SolidWorks, really because it is more dominant in that area. Hobbyists use Fusion 360 a lot, because Fusion 360 kind of positioned itself to be very easy to access, and it's cloud-based, but their pricing is very different than SolidWorks. Very recently, SolidWorks actually did a very good move, and they made a maker version of the software available. So before, for example, last year, if you wanted to access SolidWorks, you have to go through some organizations, or you have to go through some nightmares to. It was very hard to access, which why a lot of users kind of start moving into Fusion 360. This year, SolidWorks have launched a new version or a new access for makers. So that's a very affordable access at $99 a year. And you can access the software for that. So SolidWorks is now kind of aggressively trying to push on they're already in the professional dominant, and now they're aggressively trying to push and take over the place where Fusion 360 is. So that's my thoughts. I can't give you a I can't give you an absolute answer of which one should you use. Of course, if you ask a fanatic user of Fusion 360, they're going to say Fusion 360, and vice versa for SolidWorks. Any other questions? Okay, that's about it. So thanks a lot for joining. So here's my email address, taysir@t4design.com. You can feel free to reach out to me directly at any time with any thoughts or questions that you have. You can also check out the T4Design School at school.t4design.com. And if you happen to be in Hong Kong, do come visit us at the Galaxy in Kwai Chung. A couple of concluding remarks. So we have the session is recorded. I hope I get the recording functions correctly. Sometimes I mess it up, and if we got that right, we will have a recording of this session. And so after this session, you're going to receive a number of emails from us. You're going to receive a recap email of what we talked about, and you're going to receive an email once the recording is available. Most likely, we will not have the recording available for a long time, so maybe a week or something like that. And so we're going to send you an email when it's available and how to access it. We're going to send you another email before it goes away. So then if you want to capture anything from it, you can do that. Another set of things we're going to be sending your way is, if you're here and you're probably interested in parametric and 3D modeling softwares, we have designed what I would call a K-Byte knowledge series. So we'll enroll you on that as well, and every week you'll probably receive a small email with a couple of paragraphs on a little piece of information to just get you to know more about the subject. However, before we enroll you in that, we will send you an email that, okay, we will be enrolling you in that. If you do not want to be enrolled in that, just reply with a no, and then we will not do that, just so we don't spam you, or we don't send you emails that you don't want to have in your inbox. And that's about it for the session. Thanks a lot for joining. It has been a great session. Thanks a lot for everyone who participated in the chat. And do check us out at the T4Design School. Check out my LinkedIn profile. Send me a connection request. I would be very, very happy to connect with you. Let me send my LinkedIn profile as well, again, to the chat, so you can find me in an easier way. So I hope to get connected with you on LinkedIn, and also I hope to be interacting with you more on the future. And if nothing else, we can go ahead and conclude this meeting. Again, it was a pleasure for me to be presenting, and I'm really grateful that you put up the time to join us in the session.